Hey everyone, hope everyone is doing well. Welcome to another stream. Yeah, my aim is to do this every day, but due to some health problems, I'm not able to. I'm not able to do. So probably let's hope in some, let's hope down the line, in some time once I'm fully better and good, I'll be able to get back to it. Hello, Firegun. I just saw your message. Just comment. Yeah, I just uploaded the video. How to get started on. There might be plenty of videos already out there, but I feel like that it's been asked in every stream. So probably uh, better to just put a video out there as well. Mm. Oh, you asked the same comment why you have stopped live video. Okay. Yeah, I'm not well. Just recovering. I lifted heavy in gym, so now kind of resting. That's the reason. Probably give give the video a watch as well, a like and subscribe. I don't like seeing this like and subscribe, but I guess that is important if you want to spread your video to more people. But I don't share or anything like that. I try to be under the hood. But yeah, give it a go, give it a watch. If you guys like it or if you have any suggestions, if you have anything in general, please feel free to put that in comment there, right? Any suggestion, positive, negative. Cool. So what I wanted to do today is I wanted to kind of revise my Digitra. So one of the thing I mentioned in the live video as well, if you don't revise it, so it's just like not going to gym for 2 months, right? It's the same thing. Need to keep your brain sharp. So Digitra is something that I didn't do. So want to solve problems around Digitra and some other graph problems. I had a very good list uh, that I prepared while I was giving interviews. Let me see if I can pull that up. Now this will be a part of another video also, but I had like a very good kind of a thing when I was kind of giving interviews, right? Let me bring it here if I'm able to. Yeah, this is good. So as I mentioned in that video, right, there are patterns around this. Uh, Hey, sorry, man, my audio was not there. Oh, I was then speaking on mute. Oh, I explained the whole problem on mute then. But yeah, I think it's a union find problem. So that's what I was trying to draw there. Sorry about that. I'll take answer this question before I start. A question asked in an interview: if a URL comes to you and it is invalid, how will you debug the issue layer wise? What all shall you check? I think this is a very well known asked question. If you Google it, I think some answer would be there already. Cool. So standard union find. Uh, union find has each node had its root, and then each node has its size, and then also number of nodes. But do I need to initialize it? So creating a constructor, right? So public if root of u is equal to u, then you return root of u or you return u. Otherwise, you update root of u, whatever is, find the parent of the root of u, right? And then public. Uh, Now in this, do I need to just thinking whether I should put a boolean here and then return true if it was already same. Uh, so if ru is equal to rv, you can just return false because you didn't have to do anything. Or let's return true, right? Because if they are already in union, right? Otherwise, if size of ru is less than size of rv, now what we want to say is that we want to point the root of ru to root of rv, and root of rv size of rv is plus is equal to size of ru, else root of rv is equal to root of ru size of ru is equal to size of rv. Return false because basically they you had to do the union, right? 3 is the length of the node is equal to number of edges 1, 2, 3, 4, 5, 5. So edges dot length. And but the nodes could be less. So for int edge in edges UF Hello, Unix factory factorize. Sorry, can you hear me now? Okay, cool. So where I was, so you have edge 0 and edge you have added dot now. We only want to int answer is equal to new into if uf dot union u comma v. If that is true, then you can get rid of it. Answer dot 0 is equal to u plus 1. Answer dot 1 is equal to v plus 1. Otherwise, you can't have to do anything and then you just return answer. Will it work? Cool. Analyzing time complexity of union find is always tricky. It is logarithmic plus linear. Linear, yeah. Because in this, hello, iconic Arjun. What's up? I think we're just going through this article uh, to understand the time complexity. Hello. We iterate over all the edges for each edge in our do union, which is over this function, which has the time complexity of given that both size and path compressions are employed. Consider the inverse second which grows so slowly that it is over. Okay, cool, makes sense. You are given. Okay, just cool. Um, You are given network nodes of n labeled from 1 to n. You are also given list of time travels as directed. U is the source node, V is the target node, and W is the time take. Will send a signal from node K should record minimum time it takes for all the nodes to receive the signal if it is impossible for all the nodes. So this is plain Dijktra, right? If it would have been all nodes 1, then it would have been just BFS, right? So, but now as each node has a different weight, and I assume that time cannot be negative, right? So it's positive, so it's not Bellman food, so it's Dijktra. So if I have to take first example, so I have 2. So from 2 I can go to 1, go to 3, and then to 4. My here. So we have 1. And now it's coming up. So starting from 2, Digita says that pick the one that has minimum, you'll pick one, then you'll just pick this one, and then you'll pick this one. So from 2, return the minimum time. In time 1, you will be answering all the nodes, right? So in that level, basically. In the next one, you will be answering the next. So this is in this, once you answer this, then you answer this, and then it is the max time. So whatever time it took you to reach there plus this time, that is 2. Hmm. Do I need Digitra also here? That is another thing that is coming to my mind. Or okay, minimum time it takes, right? So let's just start by first of all forming the graph. So n and n is also uh, not zero index, right? So list integer graph is equal to new array list for int I is equal to 0, I less than and I plus plus graph dot add new array list. Now once you have done this, you need to fill the graph, right? So int time is equal to times graph dot let's just read this one first. Time of 0 and v is equal to time of 1 and w is equal to time of 2, right? And let's just decrease this as well. Now graph dot get u comma add new int v comma w plain director, right? Now basically our aim is to find the minimum time, right? Does this graph have cycles? No cycles. So in director, but another thing is that minimum distance that it takes from k to each node. Int distance is equal to new int n arrays dot fill distance integer dot max value and whether that node is visited. New int no boolean n and then all should be visited, right? And count, let's say 0. Now Digitra is always based on a queue. So priority queue PQ is equal to new priority queue A comma B and A comma 2 minus B comma 2, whichever has distance less, right? PQ comma new int what is the node? I'm at K and time taken is 0. Zero, right? Now it is the minimum time when I'll reach it, right? So int at is equal to pq dot poll and total time would be math dot max of total time comma at of 2, right? If and visited of at of 0 is equal to true, count plus plus if count is equal to n, return total time because we are starting from the minimum, right? Now for int 2 is equal to graph dot get at of 0, right? Now next time possible time that it can take is time that it took to come reach here, that is at of 2 plus time it will take from here to go there, right? That is 2 of 1. But is it going to be direct? It is, there is one doubt. Let's say this take 10 minutes, this take 30 minutes, right? How about I do a DFS and go all the way down? Yeah, I think that would be another solution. Yeah, that would be another solution. So basically from K, we can do a DFS, but that won't reach all the nodes. Hmm. Yeah, I think that might be another way, right? That is, so this is like a using a queue that would be using without queue, right? I'll try that one as well. Different couple of solutions coming to the mind. So what is the weight is one, right? Now if possible time is less than distance of 2 comma 0, distance of 2 comma 0 is equal to possible time, pq dot add and new. I'll go to 2 comma 0 with possible time and then return total time. If count is equal, no, you'll never reach here, right? Cool. Visited of at of 0. At of 0 is always 2 of 0 and 2 of 0 it could be k, right? Needs to be k minus 1. I see. So might be possible that Okay, let me draw this one once. So 1 to 2. Let's change the color 1 to 2 with 1, 2 to 3 with 7, 1 to 3 with 4, 2 to 1 with 2. So we start with 1 this way and this way. So I'll go to 1. I think the answer is coming more right. Expected 4. What is happening is that I'm traveling from 1 to 2, saying that okay, I'll need 1. Then I can either travel 1 to 4 or the edge would be 7 to 3. Right, only those two edges are there. Initially I only have this. So then that is 8. I'll pick 4. I'll go to 4, right? And that would be 5. So now 1, 2, 2, it cost 1. 2 to 3, it costs 7. 1 to 3, it costs 4. And 2 to 1, it costs 2, right? So we start from node 1, can go to this and but we'll go to that and spend $1 one time, and then we are at the next thing, 1 that is already there, right? You can put 1 comma 2 in the queue, 2 comma 1 or 3 comma 4. So we are going to pick this one that is visited. The next that you are going to put is 3 comma 8, right? And I am going to pick this 4, right? Now okay, so basically the thing is that in this 4 minutes, right, distance you took to travel, that is 4, but that includes your other distance also, right? So that it took 4 minutes to reach this one. If you take this 4, then 1 is also included in that, right? Yeah, understood. So probably this needs to go away from here, and then so the distance it took to reach this is at of 1, right? That is the distance it took, and once you have all the distance, the maximum time is the answer. Total time is equal to math dot max of That means that we are never able to reach this, right? Then -1, otherwise total time. Mm-hmm. How, why can't I just do this? Total time and -1. Mm-hmm. Oh, okay, okay. This might be -1, but if this is negative. Mm-hmm. Nothing in chat. Okay, cool guys. In the stream here. See you tomorrow.